I often say that for the ignorant, science can be indistinguishable from magic. Take, for example, this. This is a hand boiler, sometimes referred to as a love meter. When one holds the bottom, the liquid inside seems to be defying gravity. It will rise to the top, and it will eventually look like it's going to be boiling. But what happens here? Let's start by breaking down exactly what this is. We have essentially a sealed glass container filled partially with ethyl alcohol, which has been dyed for visibility. It's sealed in a near vacuum so that virtually no air is left. What happens then is the alcohol reaches an equilibrium between its liquid state and its vapor state. Ethanol has a fairly low boiling point, about 78 degrees Celsius, 173 degrees Fahrenheit. It's therefore considered volatile, meaning its boiling point is low enough that we can observe evaporation at room temperature. Its vapor pressure at 20 degrees Celsius, or 68 degrees Fahrenheit, is about 44 millimeters of mercury, just under 6 kilopascals, or 85 hundredths of a pound per square inch. Heating it to just above room temperature, 30 degrees Celsius, 86 degrees Fahrenheit, the vapor pressure jumps to around 79 millimeters of mercury. That's 10.5 kilopascals, or 1.5 psi. So let's make this an ideal scenario. The temperature inside the hand boiler is a uniform 20 degrees Celsius. Putting your hand on the bottom will raise the bottom to 30 degrees Celsius, while keeping the top roughly the same. This means that the vapor pressure of the lower bulb applies an additional 5.5 kilopascals, or 0.65 psi, beyond the pressure in the tube. It's important that the tube ends like a straw at the bottom of the liquid, so only the liquid can be transferred, not the vapor. The difference in pressure pushes the ethanol upward until it reaches the top bulb. This is, in essence, how barometers work. When air pressure rises, the mercury is forced upward into a tube containing only mercury and mercury vapor. So yes, there's a limit to how far the liquid will rise, and it is a function of the difference in pressures and the density of ethanol. As you can see, the limit has not been reached with this hand boiler. But does it really boil? Not so much. Boiling occurs when vapor pressure exceeds atmospheric pressure. Inside of this, however, the two are the same, so it never truly boils. The equilibrium just shifts. So then what is making it look like it's boiling? Since the tube is shorter than the maximum height the liquid would have to rise to reach equilibrium, it continues to have a suction effect, even when most of the liquid is gone from the bottom. However, at that point it can only draw vapors, which rise up in the liquid and create the bubbling effect. So, is it magic? No. It's something even better because it's real. It's science.